Lesson 9-1, adding and subtracting polynomials. First thing I wanted to go through is some vocabulary words. A polynomial is a monomial or the sum of two or more monomials that are not like terms. Some polynomials have special names, and one of those is a monomial. A monomial is just a number, a variable, or a product of a number and one or more variables with non-negative integer exponents. A binomial is the sum of two monomials, and a trinomial is the sum of three monomials. So we got monomials, one term, binomial, two terms, trinomial, three terms. And each term is separated by a plus or minus sign. So an example of a monomial would be like AB. Binomial could be 4A plus B. And a trinomial could be 4A plus BC plus C. I have three different terms, all separated by plus or minus signs. So here's one term, two terms, three terms. In the binomial, one term, two terms. In a monomial, there's one term. The degree of a monomial is the sum of the exponents of all the variables. So an example, if I had a to the fourth, b to the seventh, this would have a degree of 11. I just add the exponents. A non-zero constant has a degree of 0, and a 0 has no degree. So if it's just a plain number, it doesn't have a degree, it just be a degree of 0. Now a degree of a polynomial is the greatest degree of any term in the polynomial. So if I had a to the fourth, b to the seventh, plus a to the fifth, this would have a degree of 11 because the term that has the biggest degree, 11, would be the degree of the whole polynomial. You can find the degree of a polynomial by finding the degree of each term, and then the polynomials are named by their degree. So I would first put them all in order, or add up all the degrees in each monomial, and then determine which one is the largest. One that has the largest is the degree of the whole polynomial. A couple other types of polynomials and their degree names. So if it's got a degree of 0, it's a constant. So a constant would just be a number. So if I said 4, that has a degree of 0. Linear means that has one degree, which means it's just a exponent. So if I said x, that has an exponent of 1. You're not going to see that 1. It's just going to be plain x, but just know that that is linear. So think of y equals mx plus b. That's a linear line because the exponent here is just 1. Quadratic has a degree of 2 because you're going to see the biggest exponent being 2. Cubic is a degree of 3, so like x cubed. Quartic, a degree of 4, so fourth exponent. Quintic, degree of 5, so that would be exponent of 5. 6 or more, you can just say 6th degree, 7th degree, 8th degree, and so forth. If you couldn't remember these other specific names like linear, quadratic, cubic, you could just still say 1st degree or 2nd degree or 3rd degree and so forth. Addition is commutative, and therefore the terms of a polynomial can be written in any order. So commutative means you can switch the order of the addends, it'll still be the same. However, the standard form of a polynomial has terms written in order from greatest degree to least degree. And then that is important because when you have the polynomial written in standard form, then you can find the leading coefficient. And the leading coefficient of a polynomial is the coefficient of the first term of the whole polynomial. But in order to do that, it has to be in standard form. What we're going to do in our first examples is determine whether each expression is a polynomial. If it is a polynomial, then you find the degree and determine whether it's a monomial, binomial, or trinomial. First one, 8ab minus 2c. This one is a polynomial, so yes, it is a polynomial, and I have 2 degrees, so this would be a binomial. Letter B, negative 11.25. Negative 11.25 is a polynomial. This is one term, so this is a monomial. And this has a degree of 0. I forgot to do the degree on the other one. This one has a degree of, this one has 2, this only has 1, so this would have a degree of 2. Letter C, 2x to the negative second plus 3xy. Because this one has a negative exponent, for polynomials, you cannot have any negative exponents involved. So this is not a polynomial. And because it's not a polynomial, it doesn't have a degree, and we can't determine what kind of polynomial it is. Next one, you look at the degrees. This has a degree of 3. This has a degree of 1. This has a degree of 1. This has a degree of 0. Since this is a polynomial, so yes. This has 1. And then even though there's 4 terms here, these two can be combined to make negative 3x. And I only have 1 term, 2 terms, 3 terms. So this is a trinomial. And this would have a degree of 3 because the biggest degree of all 3 terms is 3. And our last one here, letter E, there are no negative exponents. So we would have this, yes, as a polynomial. There is nothing to combine, so I have 1, 2, 3 terms, so this is a trinomial. And the degree, this has a degree of 2, this has a degree of 2, this also has a degree of 2. So we would say this would be a trinomial, has a degree of 2. Another example, here's all in a table format. So first one, 2a, is not a polynomial. 2a is a polynomial. So yes, has a degree of 1, and it is a monomial. Next one, 7x squared plus 21x minus 48. Yes, that is a polynomial, has a degree of 2, and it has 3 terms, which would be a trinomial. Next one is each term is made up of variables and or numbers. There's no negative exponents, so yes, this is a polynomial, has a degree of 3. How did I get 3? Because I have 2 here and a 1 here. 1 plus 2 is 3. I have 2 terms, so this would be a binomial. And the last one, I notice I have a negative exponent, so no, this is not a polynomial. Therefore, I don't have a degree or any classification. And a couple other examples. Here I have a negative exponent, so is it a polynomial? No, so I don't have a degree or classification. Next, yes, this is a polynomial that has a degree of 3, and I have 3 terms, which would make it a trinomial. Letter C, yes, this is a polynomial. It has a degree of 1, and it's a monomial because I only have 1 term there. And the last one, yes, that is a polynomial. It has a degree of 1, and it's a binomial because I have 2 terms. Example 2, we're going to write these in standard form and identify the coefficient. So this has a degree of 1, degree of 0, degree of 3, a degree of 2. So I put them in order. Keep the signs in front of each coefficient with that number. So I need to put 2x cubed first, minus the 3x squared. plus the 4x plus the 12. You'll notice that the exponents of our x's go down gradually until you don't have any x's. So that's our standard form, and the leading coefficient would be 2. Next, this is degree of 1, degree of 5, degree of 3. Write it in standard form, so this would be negative 2x to the 5th plus 3x cubed plus 11x. And our leading coefficient would be a negative 2. Other examples, write this in standard form. So this has degree of 1, 2, 0, 3. 3 is bigger, so I put negative b cubed. Then I have minus 10b squared, then a positive 5b, then a positive 35. And the leading coefficient of this one is a negative 1. Next part of our lesson is adding polynomials. When you add polynomials, it involves adding like terms. When you add polynomials, you can group like terms by using horizontal or vertical formats. It doesn't matter to me which one you use. I'll show you both methods. Just keep in mind for like terms, they have to have the same variables and the exact same exponents. And the only thing that you're adding together are the the coefficients. So if I'm adding 3x squared plus 9x plus 27, that polynomial with 2x squared plus 4x minus 12. You'll notice that 3x squared and 2x squared, they have the same variables and exponents. So I combine those. 9x and the 4x are like terms, and then 27 and 12 are like terms. So my final answer would be 5x squared plus 13x plus 15. That's if you did it horizontally. Vertically, you just line up the terms right underneath each other and then add straight down. Here you can see the first polynomial and the second polynomial, and then add straight down. So for our first example, find each sum. I'm going to write these as vertical just to make it a little bit easier. So 10 thirds x squared minus 4, and now I'm adding 2 thirds x squared minus 9. So if I add straight down, 10 thirds plus 2 thirds is 12 thirds. 12 thirds is the same as 4, and our variables stay the same, so 4x squared. Negative 4 plus a negative 9 is a negative 13. So my answer would be 4x squared minus 13. Next one, if I were to put this in order, I would put this in biggest degree to smallest degree. So I have a negative x squared plus 0x. I don't have any x's there, plus 8. The other one I have a positive 2x squared, a positive 4x, and a minus 9. Now you might be wondering why I put that 0x, just so I have a number that I'm adding to 4x in here. So negative 1 plus 2 is a positive 1x squared plus 4x minus 1. Next example, if I were to do this one horizontally, I would just look at the biggest degree, which is the c squared. So 1c squared plus 2c squared is 3c squared. Then I have a minus 3c plus a positive 22c, or think of it as 22c minus 3c is a positive 19c. And then I have negative 22 plus a negative 12, which gives me a negative 34. So my answer would be 3c squared plus 19c minus 34. This next one, x squared would be my biggest degree, so I have 2x squared plus 4x squared gives me 6x squared. 9y plus a negative 4y is a positive 5y. And our last one, negative 13 plus 28, 28 minus 13 would give us a positive 15. And here I have a negative 1m squared plus 1m squared. They cancel each other off, and I'm left with m plus 11. More of them. find each sum, write your answer in standard form. So here we're going to put them in standard form like I was doing before. I was still putting them in standard form. So I have 20y squared plus a negative 13 squared will give me 7y squared. 12y plus 1y is 13y. And negative 2 plus a negative 10 is a negative 12. Next, negative 1b squared plus, here I got to distribute the 2. So this is 2b squared plus 1/4 b minus 2. So I have negative 1b squared plus 2b squared equals b squared. Then I have negative 1/4 plus 1/4 is 0. And then I have 2 plus a negative 2, which is 0. So my answer is b squared. And our last one here. This one doesn't have a f cubes, but I have a 3f cubed. So I have 3f cubed. I have 5f squared plus 1f squared is a positive 6f squared. I have negative f plus a negative f, which is a minus 2f. And then 5 left over. So my answer would be 3f cubed plus 6f squared minus 2f plus 5. Next is subtracting polynomials. So you can subtract polynomials by adding its additive inverse. To find the additive inverse of a polynomial, you write the opposite of each term of the second polynomial. So again, you can use horizontal or vertical to find them out. I'm going to do this vertical. I'm going to rewrite this first one. So this would be negative 7x cubed minus 8x squared minus 13. And since I'm subtracting this one, I'm distributing a negative 1. So I'm subtracting 8x squared, and I'm subtracting 20. Now from here, I just need to add straight down. So negative 7x cubed plus 0 is negative 7x cubed. Negative 8x squared plus a negative 8x squared is a negative 16x squared. And negative 13 plus negative 20 is a negative 33. Here you can see the same thing horizontally. Here you can see they distributed the negative 1 here and got negative 8x squared and negative 20, and then combined like terms. So here's your negative 8x squared, and here's your negative 13 plus negative 20, and you still get the same answer that we had before. Vertical, you can see it vertically just the way I had it. The only difference here, I didn't put this as 0x cubed in there, but you may do that. Also with subtraction, a set is closed under an operation if for any number in the set, the result of the operation is also in the set. So when they say closed, it just means it's true. So a set may be closed or true under one operation and not closed under another. Adding or subtracting integers results in an answer. So this set of integers is closed under addition and subtraction. When you add or subtract polynomials, you are combining like terms. So just pay close attention to the signs in front so you know if you're supposed to add or subtract them. This results in a polynomial with the same variables and exponents as the original polynomial, but possibly different coefficients. So make sure you do not change any exponents or variables in there. The sum or difference of two polynomials is always a polynomial, and the set of a polynomial is closed when you're adding and subtracting. So let's take a look at some examples here. Even though it says do it horizontally, you could do it vertically if you want to. This one, 6x minus 2x is 4x. Negative 11 minus a negative 19 really means I'm adding 19. Remember, you're distributing a negative. So negative 11 plus 19 is a positive 8. So our answer is 4x plus 8. Next, I have 4p squared, and I'm going to distribute. So this would be a minus 8, a minus 5p, and a positive 6p squared. So 4p squared plus 6p squared equals 10p squared. Negative 2p plus a negative 5p is a negative 7p. And I have a minus 8 at the end. Next, they distribute here, and I have a minus 2t plus t squared. My answer would be 1t squared plus 1t squared is 2t squared. Negative 12t minus 2t is a negative 14t. And then I just have a minus 4 at the end. Next, we're going to do this vertically. I'm going to distribute this one first. So now I have a negative 3x squared, which means I have a positive 3x squared, a minus 7x, and a minus 14. Now, the other one, I have a 1x and a positive 2. I don't have any x squared, so I'm just going to put up 0x squared, and then I add straight down, and I get 3x squared minus 6x minus 12. Second one, I'm going to put it in standard form first, so that gives me q squared plus 9q minus 2, and if I distribute a negative 1, that means I have 0q squared, I have a minus 1q, and a minus 3. Add them together, and it gives me 9q squared plus 8q minus 5. And our last one, I have 2x squared minus 2x plus 3. If I distribute, that gives me a negative 3x squared, negative 4x, and a positive 5. If I add straight down, that gives me a negative 1x squared minus 6x and a positive 8. Example 5. Find each difference and write your answer in standard form. So here I have 1z squared minus a negative z squared. So I'm going to do plus a negative plus 3. So 1z squared plus 3z squared equals 4z squared. 2z plus a negative 9z is a minus 7z. And then I have a minus 5. And that's already in standard form. Next, change the signs. So now I have 7r squared plus 16r squared gives us 23r squared. 8r plus 7r is 15r. And then negative 14 plus 3 will give us a negative 11. And then our last question, we have just change all the signs, so plus a negative, plus, and a minus. So I have negative 1h squared plus a negative 5h squared gives us a negative 6h squared. Here I can combine h and negative 3 halves. So this is really 2 halves minus 3 halves is a negative 1 half h. So negative 1 half h minus 17 halves h would give us negative 18 halves. Negative 18 halves is a negative 9h. And then I'm left with a positive 2. Now with word problems. Today's recording artist can sell hard copies A and digital copies D of their album. The equations H equals 9W plus 52 and D equals 35W plus 126 represent the number of albums in thousands. One artist sold in W weeks. Write an equation that shows how many more digital albums were sold than hard copies X. Then predict how many more digital albums were sold than hard copies in 52 weeks. So it says we are doing finding how many more. That means we are subtracting. So what are we subtracting? Digital. The digital was 13W plus 126. And we're going to be subtracting from that hard copies. So we're going to be subtracting this one. So if I subtract it, I'm subtracting 9W and I'm subtracting 53 from it. So when I do the subtraction, I now have 4W plus 126 minus 53. 126 minus 53 would give us 73. So this is how many more they would sell. And now they're telling us in 52 weeks. So if I put 52 in for W, 4 times 52 plus 73 would give us an answer of 281. Now remember, this is in thousands, so this would be 281,000 albums. Next, after a new recycling program was introduced, the total number in thousands of pounds of waste collected is represented by W, and the number of pounds of recyclable material waste collected is represented by R. The equation is W equals 25M plus 100, and R equals 2M squared minus 7M plus 4. Model the number of pounds of waste and recyclable materials collected in a year, where M is the number of months since January. Write an equation modeling the number of pounds of non-recyclable materials and collected by the town for this time period. Then if these trends continue, how many pounds of recyclable material will the town collect after 2 years? So we're going to have N is equal to waste minus recyclables. So if I set that up, I'm going to have N equaling our waste. Our waste is 25M plus 100. And I'm going to subtract from that 2M squared minus 7M plus 4. When I'm subtracting it, I change the signs. So now I have, and put this in standard form, I would have a negative 2M squared plus 32M. 100 minus 4 is a positive 96. That would be our equation that we're going to be using. And now we have to determine if the trend continues, how many pounds of recyclable material will the town collect after 2 years. Since we're only looking at how many recyclables, I'm going to use the R, which R would be here. And in 2 years, M stands for months, so that would be 24 months. So I'm going to have 2 times 24 squared minus 7 times 24 plus 4. And when I put that in my calculator, I end up getting 988. Now remember, it says that this is in thousands. So this is 988,000 pounds of recyclables. Next, the total number of students T would then a college consists of 2 groups: students who live in dormitories on campus D, and students who live in apartments off campus A. The number in hundreds of students who live in homerooms and the total number of students enrolled in the college can be known by the following equations, where N is the number of years since 2001. So T is the total, and D is those who live in the dorms. What we want to do is write an equation that models the number of students who live in apartments. So if we take the total minus the dorm students, that's going to give us those who live in the apartment. So if we take 17N plus 23, and we subtract from it 11N plus 8, so subtract 11N plus a negative 8, add straight down, and that gives us 6N plus 15. Now it says predict the number of students who will live in the apartments in 2020. So based on what we have here, it says used since 2001. That is 19 years. So if I do 16 times 19 and then add 15, that should give us the number of students who live in apartments. So 6 times 19 plus 15 would give us a total of 129. So if this is in the hundreds, I would just have to multiply this by 100, and that would give us 12,900 students. See, what do you need to assume in order to predict the number of students who will live on campus in 2020? Since you're only looking at the students who live on campus, you have to assume that the total number of students does not include students who commute. Okay, because those are neither on campus nor in the apartments there. So those who live on campus don't include students who commute. So that is our lesson on adding and subtracting polynomials.